So welcome back to our new video. In today's video we will be working on project number 5, that is loan status production using SVM. So before beginning, let me tell what SVM is. So it will be a quick guide to SVM. So SVM is a classification technique in which we try to differentiate between two entities. So what we do, first we plot the points in 2D graph, and based on the decision margin, you can say decision boundary, we try to maximize this margin gap. More the margin gap, our better model will be. Okay, so if the data point is on either side, so we can predict whether it is uh, whether it is classified or not based on the either of those side. If the point lies on the left hand side, it belongs to some A class, and if it belongs to the right hand side, it belongs to a B class. So that's how SVM works. Now let's get back to our dataset, what we'll be using. So we will be working on load status prediction, and the Kaggle data set link will be provided in the description below. So the data set has 13 columns, and you can see all its gender, married, dependencies, all these are the properties. And the last one is the loan status. Y means the loan is approved, and N means the loan is not approved. So there are total of 381 rows. Okay, so you can download it from here, and then coming back to our collab, you can use upload files button to upload file. Now let's start. First we will import libraries. As np and import cbond as sns, then it's from sklearn learn.model selection, import train template from sklearn.metrics, learn.metrics, import accuracy score, CYCSCOR. Then we have from sklearn import SVM. So as I've already told all these libraries in my previous videos. So Panda just for uh, putting our data into pandas data frame, and numpy is for using numpy arrays, SNS for building drawing graphs or plots or scatter graph, etc. Then we have train test split, that is used to split our data into training and test dataset. Then we have accuracy score, that is used to predict how accurate our model is, and the sixth one is SVM, that will be used to train our model. Just run it. Now we will collect data. So data collection and pre-processing. So let's say it's just loan dataset. Loan dataset is equals to pandas.read.csv. That's correct. Okay, so now what is the name? Loan status production. Loan status, I think loan status production small status production. Now just run. Okay, now printing first 5 rows, loan dataset dot head. Yeah, so it will print all the first 5 rows. So we can see in this dataset what we can see, that we have first loan ID, that loan ID, then we have gender, married, dependent, education, and most of the columns has a text value like male, female, no, yes, graduate, not graduate, no, yes, urban, rural, and loan status Y. Okay, so what we will do, first, later on we will replace male and female with numerical values, all the text values with a numerical value, so that our model can evaluate and analyze it properly, because our model does not know the textual meaning, what the text is. It converts it all to a vector, or you can say numerical value. Okay, so let's say print number of rows and column, loan dataset dot shape, 614 rows and 13 columns, and then we will print how to check if there are missing values or not. Printing missing values. So loan dataset is null is sum. So there are some missing values in the gender column, some in married, some in dependency, and self-employed, loan, and credit history. So what we can do in this dataset, as we have a lot of sample size, so we can drop the missing values. So loan dataset is equals to loan dataset dot, yeah. So what it will do, it will drop the rows that have missing values. Now we will again check for missing values. Its loan dataset is null is sum. So our dataset does not have any missing values now. Now to check, just let me reprint the number of rows and column, just to show you that number of rows are now decreased. So as you can see, now our sample size has 418 rows with 13 columns. Okay, so now what we can do is, let's see how many in this dependent column, just a minute, yeah, in this dependent column, let's print how many numbers are there. As we can see that there are two variables, male and female, and urban, rural, and yes and no, but I need to know about the dependent, that how many values are there in dependent column. So to check it, printing dependent dependent column values, loan dataset dependents dot value count. It's a function, so let's print it. So as you can see, there are 4 values, 0, 2, 1, and 3 plus. 0, 2, 1 is okay, but I have to replace this 3 plus. So what I can do, replacing 3 plus with 4. So 3 plus, let's say 4, so that our model can analyze the data, because 3 plus is a string, it's not a value, numerical value, it's a string. So we will replace it. So loan data set dot replace to replace, yeah, it's correct. So what we are doing here, so it's a basic syntax replace, and what we have to replace and what the value we have to replace, we have to write out here. Then we will just print it. Now we can print again, we can print dependent column. Just I'm I to use copy paste it, so it will print. So our 3 plus has replaced with the 4, and the dataset looks good. Now to check, now let's visualize our data. That's why we will use SNS cbond data visualization. So what we can do, let's use count plot, and on the x-axis we will use, and you, yeah, it's correct. So what it says that the number of graduates who are the number of people who are graduated gets more than 250. There are 250 people who are graduate and got loan approval, but there are around 70 or you can 65 around people who are not graduated but still got the loan approval. Okay, so these are kind of helpful to see, to visualize our data, to analyze our data, that how, what model can we use. You can use logistic regression also. Now let's go with replacing, or first let's find the relation between marital marital status and loan status. Let's find people who are married and people with not married. Let's see the relation between the loan. Okay, so people who are married are getting loans like around 225 around people are getting loan, and people who are not married are not. So they are kinda, so people with who are married are getting a loan as compared to the who are not married. Okay, so you can do it for the other columns as well. So now let's converting categorical columns uh, to numerical values. Numerical values. So loan data set dot replace married, yeah, select. So what we are doing here, so we are replacing no with 0 and yes with 1. Same goes with gender male, we will replace male with 1, female with 0, and self-employed with self-employed, no miss no is replaced with 0 and yes is replaced with 1. And we will do for property area also. Property area also. Then we will do education is also done and in place. So if what does in place true, that we have to replace. If we will not use in place true, then our data will not be updated. To update our data, we will use in place true. So now let's print first 5 rows again to check. So our data has now changed. That's good. But there is one missing. I can see loan status has not been changed. So just let me change the loan status as well. loan status, it's capital status, let's say we will convert n with 0 and y with 1. Now let's print again. Now the loan status has also changed. Now what will we do? We will separating the data and the label. X is equals to loan data set dot dot column ID in column loan status. So I have dropped the loan ID. Why? Because it does not add significance to our while training our model. I don't IDs. So we dropped the loan ID and loan status because it is the target variable. That's why we dropped it. And y has the target variable, that is the loan status. Okay. Now we will print x and print y. So we have the whole data, access all the columns excluding loan ID and loan status, and y has the output variable, and all the data has also changed to its numerical form. Now we will train our data. First, splitting our data to test and training data. So x test yeah, that's correct. So we have used 10%. Let me take 20, it's better. So we have used 20% of the data as test and test data, and remaining 80% as training data. Now we will train our model. Training our model using SVM. So classifier is classifier is equals to SVM. Now training classifier.fit when we have x train, xy train, it's correct. So now our data is analyzing data and training and learning. Okay, it will take some time. So what we can do is write another code. Accuracy score on training data, x train prediction, x dot predict, yes. Okay, it's correct. Now we'll print training data accuracy. Let it finish first. Yes, print another accuracy score on test data, test prediction. So our model has, let me read this. So our accuracy is coming out to be 77.8%. That is good. Any accuracy greater than 70 is considered as good accuracy score. So what we did, so here in this line we are training our model using trained data. We are providing all the columns in the that are in the X train, and also providing the output, what the output is. So using the supervised learning, our model is learning and plotting points using SVM. Okay, then we have predicting the accuracy score. So what we did here is we gave the trained data that we used to learn that we use to train our model, we use the same data set to predict whether it is giving the correct answer or not. Okay, then our model is predicted, all the predictions are stored into the extrained prediction, then we used it to compare it with the original. So original output with the predicted output, it will give us the accuracy score. The accuracy score is coming out to be 77.8. Then we will use test data, so our accuracy is coming out to be 81.25. That is great, that is great. Okay, now we will create predictive system, test system, input data is equals to, we will fill it. Just let me complete the rest of the code first. Input data as numpy array is equals to np dot as array, then we input data, then input, then input data reshaped, we will reshape it, is equals to input data as numpy array dot reshape, and we'll pass the parameters -1. Okay, then we have prediction is equals to classifier. Yeah, so let me get the input. So it's okay, so these are on the numerical, these are on the text side, so we can, what we can do is print first 5 rows, or you can say we can take these values. Let's see, I'm taking the first row as the input data and the answer is 0. That means commas, 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 because in this we don't need to again convert it to numerical form. And then this, so our output is 1 and the output is here is 0, so it is incorrect. So, and our model is 80% accurate, so what we can do is we can take another output, another input, or you can simply ask Gemini to do it for you. Just a minute. Add create list. Yeah, so Gemini will do it for you. Just paste and rerun it. So it is approved. What was the output? Output is 1. So our output is correct, it is 1. Just let me read it, it does not require. Okay, so this is for now. We use SVM to predict our data. If you have any confusion, let me know in the comments, and do not forget to like and subscribe. Thank you very much.